Hello, champions. Good morning and welcome to the live Q&A session on Robotics 101. This live session is brought to you by your tutor on Schoolgate's Platforms Innovations. And in today's session, we're going to be answering just a few questions received, and possibly if you have one or more questions, we can also, if time permits, revisit them. So like I said, today we're going to be answering few questions on Robotics 101 course. But before we begin, as usual, we need to set in some rules. As in any class, there are always rules and regulations. So we are going to have some rules to guide us in this session. So let's visit some of our rules in this class. Now make sure you turn off all your mics. All mics should be turned off. Please, if you have any questions, that is number 2, always raise your hands up in the comment section whenever you have a contribution to make, and no unnecessary messages in the comment section. Fourthly, do not leave the class unless you are permitted to do so. So with these few rules we have set, they will be able to guide us in this class so that we can have a smooth learning in this class. So having said that, if you are with me in this live session, I want to be sure, just put your hands up in the comment section. Put your hands up in the comment section. Let me see and be sure you're with me. And while we wait for others to join us before we visit the questions received, if you have any question, just pen it down and type it in the comment section as well. If you have any questions pertaining the Robotics 101 course, just put it down in the comment section, and if time permits us, we are going to visit it before the end of this class. Otherwise, we will push it till our next live session, which will be coming up shortly again. So without wasting much time, after our last live class, we received a question. We received a question from Chinecherem Ikejide. And the question is, hello, please can you tell me the difference between circuits and insulators? This was the question received a few days back. This student is asking for the difference between circuits and insulators, and I'm sure you all know what circuits are and what insulators are, but for the sake of these questions, we are going to revisit it again and make sure you have a proper understanding of what a circuit is, what an insulator is, and also what is the major difference between, or what are the major differences between circuits and insulators. So if you have any contribution, like I said, always pen it down in the comment section. I will see it and read it out. So let's provide an answer to this question. Now, before knowing the difference between circuits and insulators, we need to first of all understand it from the basics. Yes, we need to understand this question from the basics. Now we know we have talked about conductors, we've talked about insulators and circuits. So let's start from the basics. First of all, what is a conductor? What is a conductor? And in our previous classes, or in our Robotics 101 course, we were told that a conductor is any material that allows electric current to flow through it. Yes, conductors are simply materials that allow the flow of electric current. Now, any material that allow electric current to flow through it is simply a conductor. And examples of conductors include your alligator wires or your crocodile clip. You can see with me here, I have an alligator wire, or crocodile clip. You also have your connecting wire. Yes, connecting wires are also good examples of conductors. Why are they conductors? Because they allow electric current to flow through it. We also have with me here a paper clip. Yes, a paper clip is an example of a conductor because a paper clip allows the flow of electric current. And also most metallic objects, yes, you can see this paper clip is a metal object, yes. If you notice very well, all the items we've identified as conductors are metal in nature. You can see them, they are metal in nature, and that hence they allow the flow of electric current. So whenever you see a metal object, it is a conductor. It is most likely going to be a conductor because it's most likely going to allow electric current to flow through it. Now, these are what conductors are. Conductors are simply materials that allow the flow of electric current, and we saw few examples of them even during our Robotics 101 course. We saw that aluminium foil is also a good example of conductor, metal spoon, copper wires, and also, like I said, most metal objects. Having learnt what conductors are and we now know what a conductor is, let's move further to the question. The question was, what is the difference between insulator and a circuit? So now, what is an insulator? What is an insulator? Remember we said conductors allow the flow of current, are materials that allow current to pass through it. But on the other hand, insulators are those materials that do not allow electric current to flow through them. Yes, insulators are those materials that do not allow electric current to flow through them. Yes, insulators do not allow electric current to flow through them. And examples of insulators include rubber band. We have a rubber band. We have a paper. You can see with me here, I have a paper. I have a rubber band as well. So these are all insulators because they do not allow current to flow through them. That is why they are insulators. So whenever you see an insulator, you know that this material will not allow current to flow through it. Plastic is also a good example of an insulator. We have plastics, we have dried wood, yes. Take note, it is not just wood, but a dry wood. It must be a dry wood. For it not to be an insulator, it must be a dry wood because if it is not dry, then current will pass through it because water will allow current to pass through it. So if it has any water content in it, it will allow current to flow through it. So these are few examples of insulators: rubber band, paper, plastic, and dry wood. Now remember, just for recap, we said conductors are materials that allow current to flow through it or pass through them, while on the other hand, insulators are those materials that do not allow the flow of current or do not allow electricity to flow through them. So now, what is a circuit? What is a circuit? Having known what conductors are, what insulators are, so now let's move over to what is a circuit. What is a circuit? A circuit is a complete path through which electric current flow. Yes, a circuit is simply a complete path. Now notice, not just a path, but a circuit must be a complete path. That is, the path must be complete. If the path is not complete, then it is not a circuit. I will demonstrate that with an alligator wire. Now, you can see this is an alligator wire. from here to here. These are two ends, and we have a path here joining these two ends. If there is any break in the path, then we have broken this path. So a circuit must be a complete path. Now, I will demonstrate that further during or in the course of this session. A circuit is a complete path through which electric current flow. Now, to demonstrate this further, in the complete part of a circuit, there are three things that must be present. Yes, to demonstrate this further, in the complete part of a circuit, we usually have three things present. First of all, there must be a conductor. Yes, there must be a conductor to allow the flow of electric current through a circuit. Yes, and we have seen examples of conductors. Yes, that was why we had to start answering the question from the scratch. That was why I had to tell you what conductors are before even answering the question, because for us to understand what a circuit is, we can't understand it without knowing what conductors are. And I'm sure by now we know what conductors are, and we can identify few examples of conductors around us. Now, with me here, I will still be using an alligator wire or the crocodile clip. This is a conductor. Now, in any circuit, there must be a conductor in any complete part. It mustn't necessarily be an alligator clip. It could be your jumper wires, which when you advance in class, you will know more of. It could be your connecting wires, which you already know of. You already have your connecting wires or your copper wires, whichever one is comfortable for you to call. We also have a paper clip. With me here is also a good example of a conductor. Now we can use this paper clip to also complete the part of a circuit. Now these are what makes up a complete circuit. Number one, we said a conductor. In a complete circuit or in a complete part of a circuit, there must be a conductor. And secondly, there must be a power source. Yes, in any complete part of a circuit, we need a power source. Yes, a power source could be your 9-volt battery, just anything to power up your circuit. Now with me here, I have a 3-volt battery. Yes, this is a 3-volt battery. We have other types of battery. We have the 9-volt battery, we have the 3-volt battery, we have other forms of battery like the AA battery and so many others. But for your level now, I'm sure you are familiar with the 3-volt and the 9-volt battery. And this is an example of a power source. You can see with me here, I have the 3-volt battery with me here. So for the part of a circuit to be complete, we need a power source. An example is the battery. And lastly, we need a load. Yes, we need a load. In any complete part of a circuit, there must be a load. Yes, we need a load in a complete part of a circuit. We need a load. And example of a load we have seen, I'm sure we've seen a buzzer before. A buzzer is a load. Yes, you can see to complete a circuit when you were during your one of your practicals, a simple burglar alarm, you made use of a buzzer. Now the buzzer serves as the load to complete a circuit. We also have other examples of loads which include your LED. You can see with me here, I have a red LED. We have different colors of LED. Most likely you have seen the various colors, but these are all examples of load to complete a circuit. Now, if you take note of these two, they are more like two in one. You can see the buzzer has both a load, which is the buzzer itself, and the conductors, which is the connecting wire. So this has the load and the conductor. You can see this is a connecting wire. Now, if we connect this to a power source, it will make some sound. Yes, if we connect this buzzer to a power source, it will make some noise. And also, we have the LED. Yes, we have our LED. If we connect it to a power source, it will also give us some light. Yes, so let's try that out. You can see in a complete part of a circuit, we say we need a conductor, which are these legs. We know the positive leg is the longer leg and the negative leg is the shorter terminal or legs. Permit me to call it legs or terminal. So this is the positive terminal, which is the longer part, and the negative terminal, which is the shorter part. Now, these two terminals will serve as the conductor. Yes, these two terminals will serve as the conductor, and the LED itself is the load. Yes, the LED itself is the load. So now we have the three things or the three requirements to complete a circuit. We have a load, we have a conductor, we have a load rather, this is our load. We have a load, we have a conductor, and we have a power source. We have a power source, which is our battery. So when you connect this, remember the positive side of the battery to the positive side of the LED. You can see it gives us light. If you disconnect this, you can see the light goes off. You put it, the light comes on, you disconnect, it goes off. So this is basically what you need to know about insulators, conductors, and a circuit. But notice that while we were doing, while I explained what a circuit is, I I never made mention of an insulator. Yes, because an insulator is not needed. You don't need an insulator to complete any part. Yes, you don't need an insulator to complete the part of a circuit. So in the complete part of a circuit, an insulator is not needed. Yes, you only need an insulator you only need a conductor rather to complete the part of a circuit. So insulators and a circuit are two different things. You don't need an insulator to complete the part of a circuit. So you know what the differences are now. Yes, you use conductors to complete the part of a circuit, whereas you don't need a conductor to complete the part of a circuit. So I believe with this we have answered the question. Is Chinenye with us on this course? I'm here to see you. Unfortunately, we don't have Chinenye, but you can always go through the replay whenever you have chance, whenever you are opportune. You can always watch the replay on YouTube. Yes, you can always watch the replay on YouTube. So basically, this is the only question we had during after our last live question and answer session. And I'm sure with this, we have a proper understanding of what a circuit is, what an insulator is, and what conductors are. So with this, I want to say you should go through your you should go through the course carefully and keep learning, don't stop learning, be creative. You can do a lot of creative stuff even outside what you have learned in the course. Do a lot of creative stuff. When you encounter problems or challenges, do well to always reach out to us at Platforms Innovations. Always reach out to us via the Schoolgate website. We are always there to attend to all your questions. And with this, I hope to see you up. Okay, before we go, we have a question. Yeah, Brian just joined us and is asking, can I connect the bulb or LED directly to a bigger battery like the 9 volts battery? Wow, that's a very nice question from Brian. Brian is asking if he can connect the bulb or an LED directly to a bigger battery like the 9 volt battery. Okay, let me look for a 9 volt battery around to show you how it is. That's why you always have to send in your questions beforehand so that we have all the materials around. We have all the materials handy. So this is what a 9 volt battery is. As you can see, it is 9 volt and it is boldly written on it 9V. 9V. And this is your 3 volt battery and this is your LED. So now Brian is asking if you can connect this LED directly to the 9 volt battery. Okay, to answer your question, Brian, yes, you can, but it will burn your LED. Yes. So if you've ever connected your 9 volt battery with the LED together, most likely you will burn the LED and your LED will get damaged. Reason being that the 9 volt battery is supplying high voltage to the LED, which is capable of burning it. So to do that, you will need a resistor, yes, to connect your 9 volt battery to the LED directly. You will need a resistor. Now, a resistor is simply an electrical component that helps to resist, as the name implies. It resists the flow of voltage, the voltage coming from the 9 volt battery. It helps to reduce it, to resist it, so that it won't damage your 9 volt battery. So to connect these two together, you will need a resistor. And let me look for a resistor around to show you what a resistor looks like. Okay, I have two resistors here with me. So this is basically how a resistor looks like. You can see resistors come in different sizes and colors. Now these sizes and colors mean different things. They have different ratings which you can identify based on their colors. But when you advance in class, you will know more on resistors. Yes, you will know more on resistors, but you do not just use any kind of resistor to connect your 9 volt battery to the LED. Preferably for now, I think you can make use of probably a 1K resistor. Yeah, a 1K resistor will do. So for you to connect your 9 volt battery to the LED, you will need to do that with the help of a resistor. But if you do it directly, then most likely you will damage your LED bulb. So avoid connecting your LED bulb to the 9 volt battery. And if you've done that already and your LED bulb is not coming up, that means the 9 volt battery, the voltage that came from the 9 volt battery has damaged your LED bulb. That is why it's always advisable you make use of your 3 volt battery to connect your LED together. As you can see, when I was demonstrating, I didn't connect this 9 volt battery to the LED bulb because I know it will definitely burn this bulb, so it's risky to try that. But now with your 3 volt battery, your LED comes on. Yes, that's it. You can only connect your 9 volt battery to things like buzzer. Yes, you can connect your 9 volt battery to your buzzer and it will not have any effect on it. If we had a battery cap, we could just make use of our battery cap or battery connector to do this, but you can see because the buzzer requires high voltage, you can see once we connect it, it makes some noise. So that's the difference. So avoid connecting your LED to the 9 volt battery. I hope I've answered your question, Brian. If I've answered your question, Brian, please let me know in the comment section. Brian, are you still with us? Let me know in the comment section if your question has been answered. And I'm also yet to see Chinenye. Chinenye is yet to join us to let us know if her question has been answered pertaining the difference between insulator and a circuit. Chinenye, please, if you are with us on this live session, signify okay. Brian just responded. He said, yes, sir. Thank you. All right. Thank you, Brian. Keep practicing. And if you have more questions or you face any challenge during the course of your practice, please always do well to reach out to us via the question section on your dashboard. And whenever you send in a question, we will see it and attend to you promptly. All right, do we have any other question before we go? It's almost time to the end of this meeting, but we can still entertain few more questions if you have any. If you have any questions, kindly send them in so that we attend to them. I know some of you are not were not able to join on time because probably because of network issues, but not to worry, you can always watch the replay on YouTube. You can always watch the replay on YouTube. So with that being said, and if there are no more questions, we can bring this class to an end if there are no more questions to answer. Okay, with this said, I believe you will be able to carry out or continue learning on the Schoolgate website and practice more. And like I said, carry out more interesting projects. Think outside the box. Think of a project you can do, not necessarily the ones provided by your tutors on Schoolgate. Think outside the box, and whenever you encounter challenges, reach out to us, and we are always there to assist in any way we can. So with this said, I hope to see you all in our next live Q&A session. Don't forget, keep learning, and see you in our next session. Thank you.